The following table contains math contest scores of two teams in a high school math contest. In your answer document, calculate the mean and median. So we need the mean of each, median of each. Determine which team scored better in the contest by comparing these measures. So then a comparison. So to get full credit, that's what we need. We'll go over here, we'll do Team A, and we'll do the mean. So the mean for Team A, what we have to do here is add all these up. 8, 15, carry the 1, 10, 18, 26, 34, 42, 425. So they all add up to 425. And you divide by how many there are, which is 5. Be 8, 40, 5. So the mean is 85 for Team A. The median, we line them all up and take the middle number. So 80 is the lowest, then 83. Then 85, then 87, then 90. Got 2 over here, 2 over there. So the median is 85 for Team A. So their mean and median actually came out to be the same thing. It doesn't always work out that way. Team B. Again, the mean for Team B. We add them all up. 14, 22, 30. That's 11, 19, 26, 33, 430. We're going to divide that by 5. It'll be 8, 40, subtract 6 is 30. So their mean is 86. Median their lowest score 78, 78, 87, 87, 100, and we got 2 over here, 2 over here. So 87 is their median. So we found all those. Now we just need to compare them. In comparison, you just write a sentence, something about Team B has a higher mean and a higher median, so their scores are better. Now, that necessarily isn't the case, because if we look at all these, Team B has that 100, which really pulled their mean up. So, but comparing those, it looks like Team B has the better scores. Figure shows 4 points on the number line. Which point best represents square root of 27? Well, the square root of 25, which is a perfect square number, is 5, so it should be somewhere around 5. Well, the only one that's anywhere close to 5 is S. The graph, as shown, represents the amount of money Sarah earned at her part-time job. Which of the following equations best represents the representation between Sarah's pay and her hours she works? If we want to write in this form, which is slope-intercept form, y equals mx plus b. We got to find the m and we got to find the b. M is the slope. B is the y-intercept, where the line crosses the y-axis. Well, the y-intercept in this case is 0, so we know b equals 0. And then we got to find the slope, and the way we find the slope is just pick 2 points. I'm going to pick something like right there. Just, it doesn't matter which ones you pick. Looks like we got about 320 as coordinates of that point. Then up here, that one's a little off, but we'll use it anyway. You got 640, and then you find the slope by subtracting the y's on top, subtracting the x's on bottom. y is 40 minus 20. X is 6 minus 3. That's 20 over 3. Divide that. And 20 divided by 3. We'll go in there 6 times. That's 18. Add a decimal and a 0 since they put theirs in decimal form over here. Bring down the 0. Go in there 6 times. So it's about 6.6. And then you just plug into this right here. You plug in 6.6 right there. You plug in 0 right there. When we look over here, these have zeros. If you wanted to put that on there to make it look more like the form. So it's got to be one of those two. It can't be those two. Well, that one's the closest. So it'll be worker painted stripes for spaces on parking lot. First paint center stripe, then mark the rest of them parallel stripes, marking the sides. What I'm going to do first, split off just angle 1 and the other angles down here that we're worried about. Get rid of the extra stuff in the middle. No reason for it. We know that these two are parallel. Anytime you have parallel lines, you have corresponding angles, alternate interior angles, alternate exterior angles, all that stuff. We know that angle 1 and angle 3 are corresponding angles. So we know angle 1 and angle 3 are the same as each other. They're equal to each other. We also know angle 3 and angle 5 are vertical angles, so they're equal. Well, if angle 3 and 5 are equal and angle 1 and 3 are equal, then angle 5 has to be equal to angle 1 also, using transitive property. So 3 and 5 are the ones, and that's letter C. The power output of a nuclear reactor is 2.47 times 10 to the 7th watts. That's in scientific notation. We want to change that into standard notation. So we take the 2.4, we got 7. It's a positive 7, so that tells us to move the decimal 7 places to the right. That's 4, 5, 6, 7. In those empty spaces, you put in zeros. Remember, when you have a positive exponent, your number should be getting bigger. I'm going to rewrite it. The decimal's now at the end, so I got 24,000,000. Decimals at the end. Put in some commas. 24 million watts.